We're now going to work through this example before us. It first wants us to plot the data in the table below. So let's look at this table here. We have distance from the light source measured in meters, and we have the intensity measured in the candle power. Well, obviously the distance from the light source is going to be my explanatory variable, and the response variable will be the intensity of the candle. And the reason why we know that is because the distance you are from the light source is going to impact the intensity of that light source. So that's kind of the thinking behind it. Let's just quickly plot this data to see what it looks like. So we're going to come to our CAS calculator here. I've already put in all the distance and I've put in all the intensity. You can see what I've labeled them, dis and in for distance and intensity. Let's now just give this a quick sketch here. We'll go data and statistics. My X is distance and my Y is intensity. And as you can see, we get this right here. Now, it isn't straight, it's not linear. So what transformation are we going to apply here to make it so? It says we're going to use a 1 on Y transformation to linearize the data. This is also where we could look at our little circle of transformation here and realize that we're looking at something that looks like this. So that would be a 1 on Y transformation. That would be one of the many types of transformations we could use to help us in this situation. Okay, but here the question is literally telling us, so there's no thinking involved. So we'll come over here now. I'm going to come here, and I'm going to come here, and I'm going to call this the reciprocal of in. So R in is the reciprocal of the intensity. I could have called it RY, whatever you like, as long as you know what you've called it and it makes sense to you, and you're not kind of getting lost in all your variables. Okay, then I come here, I go equals, and I'm going to go 1 divided by then my variables, and I want it to be the intensity, the Y variable. Then I hit enter, and it gives it all to me. Now I can jump back over here again, and I can change intensity to the reciprocal of the intensity. And as you can see, I've got a far more linear line going on here. It's far more linear, but also take note of the fact that the direction has changed. It went from being negative to now being positive. So that is going to become important when we go through some multiple choice VCAR questions soon, just something to keep in mind. Okay, now it wants us to fit a line to the transformed data with 1 on Y as the response variable and X as the explanatory variable. Write its equation of the variable, write its equation in terms of the variables. So let's come over here and we'll go menu, we can go analyze, we can go regression, and then we can go show linear a plus bx, and there is our least squares regression line, and we're just going to write this into there. Okay, so let's come over here. I'm going to write it down. Let me zoom in here. So it's going to be, now this is the important part, 1 on the intensity. Don't forget to write it as the reciprocal. Then it would be 0.007 plus 0.008 times the distance. And just like that, we are all good. So all I've done is I just copied this out, 0.007, 0.008 times, in this case, the distance. And that will be our answer. Again, what people normally mess up here is they don't put it as a reciprocal. So make sure you do that. Next, it says solve this equation to predict the distance from the light source when the intensity is 55. So what we're going to do here is I'm going to sub in 55 into the intensity and go 0.007 plus 0.008 times the distance. Now I'm going to use the CAS to solve this for me. So let's jump over here. Let's go to control, add doc, add calculator, and I'm going to go control divide. This is 1 on 55 is equal to, oh, actually, I forgot to do something very important first. We're solving this thing, aren't we? Menu, algebra, solve. Then I'll go control divide. 1 on 55 is equal to 0.007 plus 0.008 times by the distance, which we'll call D. We're solving it for D, so comma D, and we're going to end up with 1.397. So that means the distance is going to be, now it will depend what it tells you to round it to. It doesn't give us any instructions here. So let's just write this as 1.4 meters. And just like that, we're done. So that's how you would approach this type of question. Hopefully you found this helpful, and I'll see you later.